We are LASSO CubeSat Tracker V3. My name is Jeffrey Monaco. I'm the site lead.
My name is Marilyn Wolbert. I'm the hardware lead and customer liaison.
My name is Matthew. I'm the project manager.
My name is Aiden Bucheister. I'm the head of engineering.
Okay, so what is LASSO? So first off, it stands for Localized Attribute Satellites in Orbit. What we're doing is we have 3 ground stations that will track the location of CubeSats. Each ground station includes a GPS receiver, a QFH antenna, software-defined radio, and a Raspberry Pi, which you can see in the picture. There's all the connections, how it's set up at each location. And we plan to use TDOA, time difference of arrival, to calculate these satellites' positions and eventually determine the orbits, which Marilyn will show you on the next slide, how it's unique to our project.
So our project is unique because we use the novel idea of time difference of arrival to track a CubeSat. Time difference of arrival works by calculating time delays between pairs of stations. These station pairs form hyperbolas from the delays and find the closest intersection of all the hyperbolas. And due to the error in the hyperbola intersections, we are given an area instead of a single point of location for the satellite. For this project, timing has been a main concern as we need a very low error to calculate where the satellite is in the sky. 1 microsecond of error corresponds to an error of about 300 meters in the sky.
So over the last 2 semesters, our group has been working on improving the existing hardware, as well as adding several new devices, such as a external DC bias tee to remove complexity, a new GPS module primarily to improve with timing because of the PPS output, creating new setup scripts so that installations can be done more streamlined and the results can be more reproducible, and updating the user manual and documentation so that future groups working on this project can more easily have the knowledge transferred that we've been working on.
Thank you, Matt. This is Aiden again. So our long-term goals for this project in future versions is that we hope to reach the 1 microsecond sample error. We have a couple of pathways to go in doing that by using a novel hardware synchronization method using the PPS signal output from a satellite using a GPS module on the ground to synchronize different hardware captures across 50 or 100 miles between different sites. We might be able to accomplish this as well using a new software-defined radio in the future. So that is something for future groups to just consider. But overall, we want to track CubeSats. We want to determine their orbit because they do not transmit a lot of positional data. They do not know where they are. So we are on the ground and we are ready to capture where they are. And we can feed that information into CubeSat teams. And then finally, the long-term goal is to make this project open for students, teachers, universities, high schools, and hobbyists. So anybody can get these parts and perhaps get a kit and be able to assemble a station themselves and connect it to a network of their own. All right, thank you for attending this lightning talk. This has been the LASSO team.